Okay, this is part 3, starting on number 5. Same instructions as before. If again you haven't really tried number 4, you should do that before we move on. Okay, so number 5, I want us to know when the function is increasing, and that's whenever its derivative, which is our picture, is greater than 0. So we are increasing, our slopes are positive, and our slopes are positive when our derivative is positive. So we're increasing in those 3 areas. So it looks like we would say 0 to 1, 3 to 4, and it looks like approximately 5.5 to 6. We're decreasing whenever we're negative, and so that would happen when my derivative is negative, I should say, and that would be from 1 to 3, and let's see here, it looks like 4 to 5.5. And do we have any local extreme values? We have a couple here. We've got x equals 1, x equals 3, x equals 5.5. So those are any place where the derivative is 0, but we have at least one place here where the derivative is undefined. Still a critical value, still something we need to indicate, and that would be at x equals 4. Notice there is no value of the derivative at 4. There is no point, so that means it's undefined. So what's happening here? Well, at 1, we go from positive to negative values, making that a max. At 3, we go from negative to positive, so that's minimum. We'll jump to 5.5. We're going from negative to positive, so that makes this a minimum. And then what's happening at x equals 4? Right before we're undefined, my slopes are positive. Right after 4, my slopes become negative. So we went from positive to negative, which means that makes it a max. And so what do you think on the graph is happening at 4 to make the derivative undefined and to give us a maximum? And you'll notice that my slopes, as I approach 4 here, my slopes are getting closer and closer and closer to 1. So graphically speaking, over here at 4, I don't know where, I don't know how high vertically, but I know as I approach 4, my slopes start at 0. So at 3, my slopes are 0, and we already identified 3 as a minimum. So I have a minimum at 3, we'll just say it's right there. And then as I head to 4, I head for a slope of 1. But as soon as I get to 4, my slope of 1, because I'm at 1 here, instantly becomes a slope of negative 2, which would look something like this. And I go from negative 2 and I get closer to 0, and I would look something like this. Again, we said 5.5 was a minimum, and we got a minimum here at 5.5. So that appears to have made a cusp, or a corner. I guess we'd call that a corner because infinity is not involved. We didn't have a slope of infinity. And that's what we usually think of with the cusp. So this is more of a corner. Okay, so then let's look at number 6. When are we increasing? Well, we're increasing any place the derivative is positive. The derivative kind of at first appearance appears to be positive everywhere. But in reality, there's a few places it's not. It isn't positive at 1. In fact, it has no value at 1. And it isn't positive at 2 because it has no value at 2. So we're increasing everywhere but that. So I guess we should say from 0 to 1, not including 1, 1 to 2, not including 2, 2 to 3, with union or in between. So that's where it's increasing. It is never decreasing because I don't have any place where the derivative is negative. And then I need to find my critical values. Notice there's no place where the derivative is 0, never crosses the axis. But there are two places where I don't have a value for my derivative, meaning my derivative is undefined. And that would be at x equals 1. And let's see, x equals 2. So the question is, are they mins or maxes? So what's going on at 1? It would appear that if I try to sketch a graph of this, and it'll squeeze it in right here. At 1, at 0, my slopes are about 1. So I'm starting off, and again, I don't know where the height is. There's no way to tell. Let's just arbitrarily pick a spot. And like right here, my slope is 1. So the graph's already a slope of 1. As I approach 1, my slope gets steeper. Now we're closer to 2. We're closer to 3, we're closer to 4, and again I'm just looking at the values of this function. So they appear to be going to infinity. So that means as I get closer to 1, my slopes get steeper and steeper. Looks like I have this. As I leave 1, my slopes are positive, but what are they? So at like 1.1, I have a very big value on my derivative, making it a very, very steep line. So like a slope of, 1,000 or 1,000,000. So how would that be possible? If I tried to pick things up and graph them here, this is a graph with negative slopes. So what we appear to be having here is in fact a vertical asymptote. And I pick things up with a positive slope heading towards a slope of 1 again. So that means I'm coming off of my asymptote heading for a slope of 1 at x equals 2. Right? It says my values are getting closer to 1, but at 2, I go from what I thought was heading to a slope of 1, and I instantly jump to a slope of 2, which would be steeper. So it looks like we were leveling off to a slope of 1, and then I instantly turn to a slope of 2. My picture doesn't really quite, let me exaggerate it. Heading to a slope of 1, and then immediately I have a slope of 2 that is in fact always 2. So that means that piece is linear. So we have a little corner here, but notice it isn't a local min or max because it isn't bigger or smaller than the points around it. And at 1 we have a vertical asymptote, so neither of these two critical values lend itself to being a local extreme value. So in fact in this one we have none. And that'll end part 3.